Alright guys, so today we're going to talk about correlation, and we have looked at a couple different scatter plots. Now, on Monday we looked at the peanut butter quality ratings versus price per serving, and we saw that quality ratings, as they increased, then the serving price also increased. It was higher, higher, lower, lower. And then you guys were asked to make a scatter plot looking at the quality ratings versus the sodium amounts. And we saw here that it was just kind of a all over the place scatter plot. Didn't really have much rhyme or reason. A lot of the data was here, but it didn't really move together positively like the other data did. So we're going to talk about what those relationships are called with a word correlation. So in your note sheet, if you could get down the definition of correlation as a statistical measure referring to the relationship between two random variables. Alright, so we're going to talk about how some variables relate and some variables really don't have anything in common. One doesn't really affect the other or have any relation to the other. So we're going to look at some different types there. Alright, so if you need to pause the video to get that done, you can do that. Otherwise, I'm going to move on to our first type of correlation. Here is a positive correlation. Okay, a positive correlation is when each variable increases or decreases as the other does the same. So this is when they're doing the same thing. As the x variable increases, so does the y variable. This is kind of the same as what we've said as increasing lines or increasing data from left to right. We're going up. Alright, so as one is increasing, the other is increasing. If you look at it as the x is decreasing, the y is decreasing as well. You'll see the difference here in these two graphs is that one has a high positive correlation and one has a low. The difference there is just that these dots are really close together and would make a really nice line. If I choose a line, that line would really fit well with those dots. This one, although it is positively correlated, as one variable is going up, so is the other, we could still put a line through it. It just is a little more loose. So our data isn't as tightly woven as this data might be. So that's positive correlation. Go ahead and in your note sheets get down this definition, and then go ahead and sketch a positive correlation and try to think of some variables that you could use as two variables that would positively correlate, and we'll look at an example here. So if we're looking at income of people versus the number of years that they've been in education, if you see here that this data tends to be as people are more educated, as they have more years in education, then they tend to make more. So we would call this a very loose but positive correlation there. So that might be an example. Don't use that example on your note sheet. Try to think of another example for your note sheet. Negative correlation is when one is increasing as the other decreases. So this looks like a decreasing line. Again, we can fit a line to this data, and our line would be decreasing with a negative slope, and we'll talk about that as we get into writing equations for these lines. But notice, as the x values are increasing, the y values are getting smaller. They are decreasing. Or if we look, as the y values increase, the x values decrease. So these variables are doing opposite movements. One is increasing and one is decreasing. Again, the difference between that high correlation and low correlation is just the looseness or the tightness of the data points. Okay, so in your note sheets, please get down a definition of the negative correlation and go ahead and plot some points that have a negative correlation and start to think about what variables might decrease as one increases. And we will look at an example. Here's an example. If we look at the GPA of students versus the time they spend watching TV in hours per week, we can see that as people spend more time watching TV, their GPA is lower. And if they spend less time watching TV, their GPA tends to be higher. So this would be a negative correlation. As the GPA increases, the number of hours per week decreases, or as the numbers per hour of TV watching increases, the GPA gets smaller. So that's just a note. It might be kind of interesting for you guys to think about your hours per week watching TV or spending time on the internet and compare that to your GPAs. And then the third type of correlation is when there is no correlation. When there is no real relationship between the two variables, we say there is no correlation. So as you see here, there's no real rhyme or reason to the scatter or to the points on the scatter plot. They're just kind of all over the place. We couldn't really fit any lines in here that would fit our data. So we say there's no correlation there, and then we don't usually put in a line because there's not one that would fit our data as a whole. So an example of that one would be maybe the number of hours you spend watching TV a day and your height, okay? Those two things aren't related. Your height is not determined by how many hours you spend watching TV, okay? So there's really no rhyme or reason to these points here, all right? So see if on your note sheet you can get down a definition to that. And then think of another set of variables that wouldn't be correlated, that wouldn't have a relationship that is either positive or negatively correlated. All right, so today, if we have some time, and tomorrow or in block day, we're going to do an experiment looking for the relationship between people's heights and arm spans in inches. So on the back of your note sheet there, you have a class experiment investigation, which we're going to go through on block day, measuring your height and your arm span in inches, and we'll have materials for you to do that. And then we're also going to have you guys plot that on an Excel sheet up at the front of the class, and then we'll look at the class data. As we look at the class data, make sure you're plotting it on your graph, and we'll get to see that relationship. Okay? All right, at the bottom of this page, there's a survey just kind of going over, did you like listening to a video rather than maybe having me explain this in class? This is maybe the first time that we've had instruction in class on a video, so I just kind of want to hear your thoughts. So if you could fill out that survey below this video, that'd be great. Thanks, guys.